Huh? Sir, this case, sir. Hello. Yes, sir. Share your screen, sir. Yes, sir. Share your screen, sir. Yes, sir. Sir. Sir, shall we start? Sir, shall we start? Sir, shall we start? Hello, sir. Hello, sir. Sir, your voice is not audible. Sir, your voice is not audible. Sir, your voice is not audible.
ಅದಕ್ಕೆ ಏನ್ ನಿಮ್ಗೆ ಅವ್ರ ಲೆಕ್ಚರ್ ಹೇಳಿದ್ರು ಡೆಂಟೆಕ್ ಮಾಡ್ರಿ ಸೇರಿ ಅಂತ ಇಲ್ವಾ ನಾವು ಹೇಳ್ತೀವಿ ಸಾಫ್ಟ್ವೇರ್ ಅಂತ ನಾನು ನೀವು ಮೊನ್ನೆ ಹೇಳಿಲ್ಲ ಅದಕ್ಕೆ ಜರ್ಮನಿಗೆ ಹೋಗ್ಬೋದಲ್ಲ ನಿನಗೆ ಏನು ಐಡಿಯಾ ಇಲ್ಲ ನಾನು ಏನಂದ್ರೆ ಅದಕ್ಕೆ ಈಗ ಒಂದ್ ವರ್ಷ ಜಾಬಿಗೆ ಹೋಗ್ಬೋದು ಫಸ್ಟ್ ಅವಾಗ ನಿಮ್ಗೆ ಐಡಿಯಾ
Sir, your voice is not audible. Sir, your voice is not audible. Sir, your voice is not audible. Hello, hello. 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 Shridar Murthy sir. Hello. Shridar Murthy sir. Shall we start? Shall we start? Shall we start?
I am ಇದನ್ನ ಜೂಮ್ ಗೀಮ್ ಎಲ್ಲ ಓಪನ್ ಮಾಡಿ ತೋರಿಸ್ತೇನೆ. ಜೂಮ್ ಎಲ್ಲ ಓಪನ್ ಮಾಡಿ ತೋರಿಸ್ತೇನೆ.
Shridar Murthy sir. Hello sir.
Hello.
Hello.
Yes, sir, it is visible, sir.
ಹೇಳಿ ಸರ್ ಸರ್ ಶ್ರೀಧರ್
Sir, screen share ಆಗಿದೆಯಾ? Is it visible?
Yes,
Sir,
sir, it is visible. Screen is shared, sir.
Yes, sir, it is visible. Screen is shared, sir.
Am I audible, sir? Am I audible?
Yes, sir. Yes, sir.
Am I audible, sir? Madam,
Yes, sir.
shall I
You are
start?
audible, sir.
Shall I
Yes, sir.
start?
Yes, sir.
Sorry for the inconvenience. Let us start the presentation.
Hello sir. 1 minute sir.
Sir, am I audible?
Yes, sir, audible.
Sir, am I audible?
Yes sir, you are audible.
Okay, sir. Shall I start presentation?
Shridar Murthy sir, wait for a minute. Good afternoon everyone.
Yes, sir.
It's our
Shall I
pleasure
start
to welcome
presentation?
Dr. Shridar Murthy SK, Professor in Department of Electronics and Communication Engineering. Dr. Shridar Murthy holds a PhD and has an impressive academic background with 24 years of work experience. He has specialized in image processing, machine learning, and embedded systems. His research contributions are notable with numerous publications in international and national journals, edited books and conferences. He has also guided research and reviewed articles in various journals. Dr. Shridar Murthy is a life member of ISTE and IETE and has held various administrative positions. We are honored to have him with us today and look forward to his valuable insights and contributions. Please join me in exciting a warm welcome to Dr. Shridar Murthy sir. Thank you. The session is over to you, sir. Shridar Murthy sir.
Am I audible?
Yes, sir. Yes, sir.
Okay. Shall I start presentation?
Yes, sir. Yes, yes, sir. You can start. Please start.
Today, I would like to discuss artificial neural networks, which are the very important components in artificial intelligence in order to process the digital images. My presentation outline goes like this. In the introduction part, I would like to discuss basic steps of digital image processing. Maybe this topic may be the repetition. Why? Because you have already come across 3 presentations in yesterday as well as today morning. After going through the basic steps of digital image processing, I would like to highlight some of the fundamentals of neural networks, and I would like to take one case study. It is my research topic itself, pattern recognition system. I would like to go through the case study in the field of pattern recognition. After that, I would like to conclude. This is what my outline of presentation today. Now let us start the introduction. Digital image processing using artificial intelligence. So generally speaking, digital image processing is nothing but the manipulating the digital images using the computer as well as the algorithms, related algorithms. This particular diagram shows you the key phases in digital image processing. It has start with a problem domain in our society as well as in our areas. We will have so many problems, so that all come under problem domain. That the problem domain, especially in image processing, it will be in form of images. That those images will be captured using the stage called image acquisition, and that will be fed to the next stage called image enhancement. Later on, it passes through the image restoration, morphological processing, image recognition. After recognizing, we need to describe the images. These are all the basic phases in digital image processing. This also includes image compression as well as the decompression, and we have one more key phase called color image processing. If you look at these phases one by one, in the next slide, they briefly introduce us what is actually image enhancement, what is actually image restoration. In this particular slide itself, I would like to highlight the basics of these stages. As in, when you acquire the images, normally through the cameras, they will be converted into the digital form. Basically, the analog images are acquired through the camera, which contains CCDs, charge coupled devices. In turn, they are quantized and sampled and quantized to become a digital image. They are normally stored in the computer at the back end as the matrix format. These images are normally two-dimensional in nature. They have x-axis as well as the y-axis. Normally, these images are represented as f of x comma y, where x comma y, x and y are the coordinates, where f is representing the intensity. So in matrix format, we are going to represent the digital image at the back end of the computer, which is in turn given to the image enhancement. Why? Because while capturing the image, it may intercept with so many disturbances. Those disturbances will affect the performance of the image processing. So therefore, it will be given to the image enhancement stage, wherein which we are going to manipulate the digital images. The image enhancement will improve the quality of the image which is captured through the sensors. They normally includes brightness, contrast enhancement, histogram equalization. This kind of techniques which we are going to use in image enhancement in order to improve the quality of the image. But so again, the next stage is also very much similar to the image enhancement only, that is image restoration. In this particular part, we normally, what do we do is, whenever we have the images, when they are kept, I'm talking about the analog images, when we kept for a long time, they will be get blurred. So therefore, when you take the photograph of that particular image, it will be in blur in nature. So the original image can be restored using so many algorithms. All those algorithms come under image restoration, in which we normally use the filters to restore the images to its original format, like Wiener filter, homomorphic filter. These filtering techniques which we normally use in image restoration in order to denoise the image or de-blur the image to get it into the original format. Then normally for image recognition, it is very essential to do some morphological operations also. Morphological operations include dilation as well as the erosion. Whenever, especially in pattern recognition, these patterns normally very thick in nature or very thin in nature. If it is very thick, that cannot be given to the next page, which may degrade the performance of the system. So therefore, we go for the erosion process, wherein which the patterns are going to be thinned. Whereas if you want to thicken the patterns, then we normally do the dilation process. So combine of these two techniques also can be done through opening as well as the closing techniques. Those who are taken image processing as their subject, they are aware of these algorithms. And after doing these kind of circus to the captured image, we normally go for image recognition, where in which we are going. If that particular image contains so many objects, then if we are interested in a particular object, we are going to recognize that particular object, and after recognition, we are going to describe that particular object. So, for example, in a medical field, if we have the X-rays or MRI images, wherein which we need to identify the diseases, where the entire image may not be of our interest. We are going to concentrate on a particular area. So after looking into that particular area, after that we are going to in the similar way, in image processing, one more area is image compression as well as the decompression. Digital images, as I earlier told, will be represented in a computer in a matrix format. They are nothing but the values, pixels. So whenever you capture an image, the large number of again, in the image compression, we have two types, that is lossy compression as well as the lossless compression. In a lossy compression, we are going to lose some information from the original image. So again, it is application dependent. So in what application you are going to make use of these images, that plays a very important role. Some information is lost, means it will not affect so much. So in such cases, we normally go for lossy compression. This is about the key phases of digital image processing. In that, one more area is color image processing. So in color image processing is mathematically complex. Why? Because color as well as the this. Color images are going to produce large data. Why? Because they are represented using three matrix. As you know, color image can be represented by mixing the three basic colors like red, blue, and green. So therefore, in order to represent these basic colors, we normally use the tree matrix. Am I audible? Is it okay?
Yes, sir. Yes, sir. It's audible.
Okay. So color images are going to produce a large amount of data. So therefore, what do we normally do? I mean, color images as well as the grayscale image. Grayscale image is again represented using a one single matrix only. One more format is binary image. This binary image contains only zeros and ones. Normally, these binary images are preferred when you go for optical character recognition as well as the handwritten character recognition. So that is what my research area, wherein which I had taken one case study. So that I'm going to discuss later at the end of my presentation. So in digital image processing, as I told, color images are represented with the three matrices. One matrix for red color, another matrix for blue color, another matrix for green color. So these basic color, in order to represent these three basic colors, we normally require three matrix. So therefore, color images produces huge amount of data. So therefore, what do we normally do is these color images are going to convert to the grayscale images. There exist so many algorithms to convert these color images to the grayscale images, and then we do the processing whatever we want based on our application. After that, after our processing is over, then we are going to revert back, means we are going to convert that grayscale image back to the Am I audible, sir? Now? Hello?
Yes, sir, audible.
Okay, okay. Why? Because I had some pop-up window here, that is why. Okay, now.
Yes, sir, it's audible.
Okay, okay, okay. So these are all the slides which I have already discussed: compression, morphological processing, representation. So all these steps can be nowadays done through some artificial intelligence techniques. Conventional techniques are also there, but nowadays we are switching over from conventional techniques to artificial intelligence techniques. Why? Because they offer more advantages over the conventional techniques. The artificial intelligence, as the name indicates, human body contains intelligence in the brain. So now, what they researchers, what they or scientists, what they do means they started mimicking the human brain in a computer system. This is the next approach. Why? Because artificial intelligence, in the artificial intelligence, artificial neural networks plays a very important role. The scientists, what they do is they started incorporating the intelligence in the computer. So that can be done by modeling the human brain. So that approach is done, and for which we need to what you call simulate the human brain into the computer. So for which we need to study how the human brain works, what is the architecture of the human brain. So for which we need medicine persons. Anyhow, the scientists they studied thoroughly the structure of the human brain. The human brain contains. Hello, sir, is it not audible? ಆಗ್ತಿಲ್ಲ, ಕೇಳಿಸ್ತಾ ಇದೆ, ಅಲ್ಲ ಆಡಿಬಲ್ ಇದೀನಲ್ಲ, ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆಗ್ಲಿಲ್ವಾ? ಓಕೆ.
Yes, sir, you are audible.
ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ ಸರ್, ಇಲ್ವಾ?
Sir, it's not visible. PPT.
ಇಲ್ಲಿವರೆಗೂ
Share
ಕಾಣಿಸ್ತಾ
your
ಇದೆಯಾ?
screen, sir.
ಓಕೆ ಓಕೆ ಓಕೆ.
Share your screen, sir.
Now is it okay, sir?
Yes, sir. Now it's visible. Continue, sir.
Is it okay, sir?
Yes, sir, it's visible.
Okay, okay. So as I told, the scientists they started mimicking the human brain into the computer system. So for which we need to study how human brain works. So for which after thoroughly studying the human brain, the scientists they started knowing the structure of the human brain. Human brain normally contains 100 billions of neurons. One neuron structure is now visible on your screen. The structure is like that, which is having the neuron body. Neuron body is normally termed as soma, which contains a nucleus. And for the neuron body, there exist so many connections. Those connections are termed as the dendrites, and these dendrites are the connections from the other neurons. One neuron, the study says one neuron in a human brain has the connection around 1 lakh connections from the other neurons. Means one neuron is having the connection from the around 1 lakh connections from after receiving the input, processing is done in neuron, and output will be produced. That output is in turn given to the other neurons through the axon. This is the axon part which connects to the other neuron. So this is how a single neuron in a human brain works. This particular neuron is modeled by the scientist, and that resulted into a artificial neurons. The artificial neurons are going to, so these are the things which I have already mentioned in the diagram. By mimicking the neurons, So all these things I have already told. So the signals, electrochemical signals are going to received. Frequently my screen is now screen is visible, na sir?
Yes, sir. Yes, sir. It's visible.
When the neuron is getting excited, that will in turn sends the signal to the other neuron. These stages are normally called as inhibition as well as the excitation. When a particular neuron fires means it is called as excitation. Sometimes some of the neurons will not be fired. That state is normally known as inhibition state. So this is what the structure of a artificial neuron. Artificial neuron contains one or many weighted inputs that will be in turn processed inside the cell body, and that is resulted into a output. If you get the output means that particular neuron is fired. If you don't get the output means that particular neuron is not fired, means inhibition as well as the excitation. If the neuron is fired means excitation. If the neuron is not fired means it is a inhibition state. So in a artificial neuron, inside that particular neuron body, we will be having the activation function, for which we are going to give the inputs. The summation of weighted inputs we are going to give as an input to the activation function. So there exist so many activation functions. Those activation functions are visible in the next slides. So based on the activation is disconnected. So sorry for the inconvenience. I'm sharing again. Please bear with me. So this is the structure here. So weighted inputs are given to the artificial neuron. So inside the artificial neuron, we will be having the activation function. Weighted sum of inputs will be given as an input to the activation function. That activation function in turn generates the output. If that particular neuron get fired means you are going to get the output, otherwise you will not get the output. So the output from a single neuron in turn connected to the other neurons. There exist multiple outputs here. So these are the some of the widely used activation functions. It is a step function. Whenever the given input is go beyond the threshold, this is the threshold point, it will resulting in a 1. If the resulted input is not beyond the threshold, means if it is less than threshold means it will gives you the 0. So this is the step function. This is the sign function. Sign functions leads to positive as well as the negative values. So if the value goes beyond 0 means +1. If it is less than 0 means it is a -1. So both positive and negative values are going to generate as an output in sine function, and this is the sigmoid function. Smooth variation is going to visible here. So this is also very widely used activation function in artificial neural net. Am I audible now? Please respond.
Yes, sir. You are audible.
Okay, okay. So screen is also visible now.
Yes, sir.
Okay. So frequently it is disconnecting. Sorry for the inconvenience. So I talked about a single neuron up to this point. Now we are talking about the networks. Means connection of multiple neurons is nothing but the neural network. That's it. So we have modeled till now a single neuron. So those modeled single neuron, if you have multiple, if you connect multiple neurons together, that will leads to a neural network. So these neural networks normally maps set of inputs to the set of outputs. The number of input neurons as well as the output neurons are going to be variable based on our application. Again, the network topology is also variable in nature based on our application. So now this is very important slide according to me. Here it is the new researchers, means those who are interested to enter into the digital image processing, especially taking the what you call artificial neural networks for their research. This will be helpful. This slide is for beginners. This particular slide targeted for the beginners, means those who are started their research. For them it is very beneficial according to me. So here we are going to consider three basic gates. We are already aware of the gates. There exist three basic gates: AND gate, OR gate, as well as the NOT gate, for which these gates can be simulated using the simple artificial neural network. This is the structure for the AND gate, and this is the structure for the OR gate, and this is the structure for the NOT gate. All these are the simple neural networks. You can see here for the AND gate, the threshold we have fixed here is 1.5, and this particular neural network receives two inputs, input 1 and input 2, and produces the output. As you can see through this particular truth table, AND gate, obviously whenever the two inputs are 0, 0, you will be getting 0, 0, 1, 0, 1, 0, 0, and 1, 1, 1. So the same thing can be simulated here using the simple neural network. Here threshold value is 1.5. So you can see here weighted some of weighted inputs are given as a given as the input to this activation function. Here the activation function here is step function, which is having the threshold point 1.5. So you can see here when both inputs are 0 0, obviously input for this neuron is 0, so therefore it is less than threshold point, so therefore it will produce us no output, means 0. When it is 0 1, then the input for this neuron is 1, again that is less than 1.5, so therefore you will not get any output here. When the inputs are 1 0, then also the input for the activation function is 1, which is again less than 1.5, so therefore you will not get the output here, that is 0. When it is 1 1, so weighted sum of inputs is nothing but 2, that is greater than 1.5, so therefore this neuron gets fired, means excited. Till now it is in inhibition state. Now when both inputs are 1 1, it will be getting fired. That state is known as excitation, so therefore you are going to get the output here. So when both inputs are 1, you are getting the output, that is nothing but 1. So this is how we are going to simulate the AND gate. The same comment holds good for the OR gate also. Here it is here for the AND gate, it is the threshold point is 1.5, whereas for the OR gate it reduces to 0.5. When both inputs are 0 0, obviously input for the activation function is 0 less than 0.5, so therefore you will not get output. So 0 0 1 means the weighted sum of input is nothing but 1. 1 is more than 0.5, so therefore you are going to get the output. For 1 0 1, for 1 1 also 1. Again for the NOT gate, the threshold point is minus 0.49, approximately minus 0.5. This is self-explanatory because I have already told you the working of AND gate as well as OR gate. In a similar way, we can have the simulation for NOT gate, for which threshold is reduced to minus 0.5. So again, now move on to the next topic, that is types of neural networks. And broadly, we have two kinds of neural networks: single layer neural network as well as the multi-layer neural networks. Literature says single layer neural networks are capable of solving linearly separable problems, whereas the multi-layer neural networks are going to solve not only linearly separable problems but also linearly inseparable problems. Many of you may not know what is the meaning of linearly separable and linearly inseparable. That can be understood by this slide. So again, I took example of AND gate as well as the XOR gate through the coordinates. As we can see, AND gate produces 0 for these 0 1 0 0 as well as the 1 0. It produces 1 only when both inputs are 1 1. So it is represented in a dark dot, whereas these are the zeros, whereas this one is 1. So if that is the case, by a straight line, you can see the line here, by a straight line, you can segregate, means you can classify them on other side. So when you do such kind of grouping by a single straight line, then those kind of problems. This is one example by taking an AND gate. So this is known as linearly separable problem. AND gate is taken as an example to understand what are the linearly separable problems. The categorization of the things with the help of a single straight line. So they are known as linearly separable problems. If you consider the linearly inseparable problems, for which one typical example is XOR gate. So you can see here, when both the inputs are same, 0, 0 and 1, 1, it will produce us 0. When both inputs are of different values, means 0 and 1, as well as 1 and 0, it will produce us 1, 1. So here in this, by having single straight line like this, you cannot segregate. If you put the straight line here, these ones are combined with this 0. If you put the line here, then obviously these ones are combined with 0. So that segregation is not acceptable. So such kind of a problem is known as linearly inseparable problems. In our day-to-day life, we will be having so many linearly inseparable problems. Those linearly inseparable problems can be addressed, as I told, using multi-layer neural network. Single-layer neural networks are capable of addressing the linearly separable problems, whereas multi-layer neural networks are capable of addressing linearly inseparable problems. Again, you can see here, these kind of networks are known as single layer neural network, which are having only input neuron as well as the output neuron. This structure is known as single layer neural network that can be that these neural networks address only linearly separable problems. I have already told you this neural network, how it simulates the AND function. Again, here threshold value are taken as 2 for x1, x2 as the inputs. We get the output. This is self-explanatory. Weighted sum of inputs we are going to give to this particular neuron. If this neuron receives greater than or equal to the threshold value, it will generate the output. Otherwise, it will not generate any output. So by that, you can understand easily this particular structure will simulate this single layer neural network, simulate the AND function efficiently. So the same thing goes with for R function. R function can also be is also a linearly separable problem that can be addressed using a single layer neural network. Now you can see here the simulation of XOR gate is not possible with a single layer neural network. It needs one more layer between input layer as well as the output layer. You are having one more layer. That layer is normally known as hidden layer. So the layers which are in between input layer as well as the output layer, they are all termed as hidden layers. Here you have only one hidden layer. It is in neural networks you may have multiple hidden layers also. You can see here this particular artificial neural network simulate the XOR function. So this can be understood very easily. So when both these inputs x1 as well as the x2 1 1, see here, so 1 into 2 this particular neuron receives 2, whereas here also there exists 1. 1 into -1 means -1. 2 minus 1 will become 1. The threshold value is 2. So therefore, this particular neuron will not produce any output here. So therefore 0. 0 into 2 means 0. So at this input you are going to get the 0. The same comment holds good for this particular link also. Here also you are going to get 0. So therefore net output is 0. This is the case when x1 and x2 both are 1, 1. When you see both inputs are 0, 0, then also obviously these neurons are going to receive 0 signal. It is less than threshold. The threshold value which we took is 2. So therefore these two neurons will not get filed. They are in inhibition stage. So therefore output from this neuron as well as from this neuron is 0. So therefore for this neuron you will be getting 0 input. So therefore this neuron is also not get filed. So therefore you will get 0 as the output. For 1, 1 as well as the 0, 0 you will get no output from this network. Let us consider 1 and 0. So when x1 is 1 and x2 is 0, let us see what happens. If x1 is 1 means 1 into 2, 2. Whereas here it is 0. So therefore 0 into -1 is 0. So therefore 2 plus 0 is 2. So therefore this particular neuron get filed. So therefore we will be getting 1 here. 1 into 2 means 2 here. So the same comment holds for this line also. So 2 plus 2, 4, which is more than threshold. So therefore this particular neuron get filed. So therefore you will be getting the output. So this is how the multi-layer neural network will address the linearly inseparable problem. These are the very, very simple examples. My intention is presently I'm targeting the new researchers, those who are not aware of the working of neural networks. For them, this is the presentation according to me. Those who are already involved in neural network, they may feel boring. Okay, let it be. Okay, so now learning methods. As I already told you, we are going to incorporate intelligence into the computer. So how to incorporate intelligence into the computer means human body contains intelligence in the human brain, as all of you know. So what we do is we are going to mimic the human brain into the computer system. Okay, how human brain learns, for which I can take childhood example. Whenever we started learning our language, means Kannada, our mother or our teacher start using this Balapa, Slato, Kannada use ಮಾಡ್ಬೋದು ಅನ್ಕೊಂಡಿದ್ದೀನಿ. Many of you are knowing the Kannada. ನಮ್ಮಮ್ಮ ನಮಗೆ ಹೇಳ್ಕೊಡ್ಬೇಕಾದ್ರೆ ಸ್ಲೇಟ್ ತಗೊಳ್ತಾ ಇದ್ರು. ಆ ಅನ್ನೋ ಆಲ್ಫಾಬೆಟ್ ಬರ್ದ್ಬಿಟ್ಟು ರಿಪೀಟೆಡ್ಲಿ ಶಿ ಇಸ್ ಟೆಲಿಂಗ್ ದಿಸ್ ಇಸ್ ಆ, ದಿಸ್ ಇಸ್ ಆ. ವೈ? ಬಿಕಾಸ್ we are in our childhood we are not aware of any patterns. When we start learning our language, so what do? We are going to write some patterns. Means our teacher writes some patterns, they repeatedly telling this is this is this, like this. Means no pattern ಬರ್ಬಿಟ್ಟು ಅದನ್ನ repeatedly they say it is a. So in the initial time, our brain are going to train. Whenever we see that kind of pattern automatically we started recognizing them as R. This is what we know as training as well as the. So after so many trains, what our teacher will do, so after a certain time they again put the same pattern, and they started asking us, what is this pattern says, what is this pattern says, ಯಾವ್ದು ಏನಿದು ಅಕ್ಷರ ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು. Means when our brain is trained properly, then normally what we do is we properly. If our brain is not trained properly, means we are going to say something else, which is again teacher started saying, so ಇದು ಲೆಟರ್ ಅಲ್ಲ, ಅದು ಬೇರೆದು ಅಂತ ಹೇಳಿ ಮತ್ತೆ ನಮಗೆ ಅದು ಟ್ರೈನ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ ಲೈಕ್ ದಿಸ್ the same thing is incorporated here as a learning methods. In artificial neural networks we are going to have three basic types of learning. They are known as supervised learning, unsupervised learning. So as I told, in a supervised learning there is a teacher involved in learning process. Means teacher is going to say what is the output. Normally we will be having the labeled data here. What are the labeled data, what are the unlabeled data, we will discuss it later. So simply just understand, supervised learning, teacher is there. No teacher will be involved in learning process, for which one example, very good example is that as a children, ಅಂದ್ರೆ ಕನ್ನಡ ಮಾತಾಡ್ತೀನಿ, ವೆರಿ ಗುಡ್ ಎಕ್ಸಾಂಪಲ್ ಇಟ್ ಈಸ್. ಈಗ ನಮಗೆ ಒಂದು ದೀಪ ಹಚ್ಚಿಟ್ಟಿರ್ತಾರೆ ಮನೆಯಲ್ಲಿ, ಮಗು ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳೋಣ. ಆ ಮಗುಗೆ ಅದು ಬೆಂಕಿ, ಅಂದ್ರೆ ದೀಪ ಉರಿಬೇಕಾದ್ರೆ ಅದು ಬೆಂಕಿ, ಅದು ಸುಡುತ್ತೆ ಅಂತ ಗೊತ್ತಿರಲ್ಲ. ಏನೋ ಕೆಂಪುಗೆ ಉರಿಯುತ್ತಲ್ಲ ಅಂತ ಅದು ಹತ್ರ ಹೋಗುತ್ತೆ, ಮುಟ್ಟುತ್ತೆ ಕೂಡ. ಆಮ್ ಐ ಆಡಿಬಲ್? ಕೇಳಿಸ್ತಾ ಇದೆನಾ? ಪ್ಲೀಸ್ ರೆಸ್ಪಾಂಡ್ ಎನಿಬಡಿ.
Yes sir, it's audible.
ಓಕೆ. ದೀಪನ್ ಮುಟ್ಟಿದಾಗ ಆಬ್ವಿಯಸ್ಲಿ ಆ ಮಗುಗೆ ಅದು ಸುಡುತ್ತೆ. ಸುಟ್ಟಾಗ ಅದಕ್ಕೆ ಗೊತ್ತಾಗತ್ತೆ ಅದು ಬೆಂಕಿ, ಅದನ್ನು ಮುಟ್ಟಬಾರ್ದು ಅಂತ. ಹಾಗಾಗಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾರು ಟೀಚರ್ ಇರಲ್ಲ, ಅಂದ್ರೆ ಅಮ್ಮನೂ ಇರಲ್ಲ, ಯಾರು ಇರಲ್ಲ, ಅದು ಹಾಲಲ್ಲೇ ಇರುತ್ತೆ, ಅಲ್ಲಿ ದೀಪ ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳೋಣ. ಸೊ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಸಿಚುವೇಶನ್. ಅವಾಗ ಅದು ಹೋಗಿ ಬೆಂಕಿನ ಮುಟ್ದಾಗ ಏನಾಗುತ್ತೆ, ಅದಕ್ಕೆ ಸುಟ್ಟು ಬಿಡುತ್ತೆ. ಸುಟ್ಟಾಗ ಅದು ಹಿಂದೆ ಸರ್ಕೊಳ್ಳುತ್ತೆ ಅನ್ಕೊಳ್ಳೋಣ. ಸೊ ಮೀನ್ಸ್ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ when it's see the same, I mean ದೀಪ ಮತ್ತೆ ನೋಡಿದಾಗ ಅದು ಹತ್ರ ಹೋಗಲ್ಲ, ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಅದಕ್ಕೆ ಗೊತ್ತಾಗುತ್ತೆ ಅದು ಸುಡುತ್ತೆ ಅಂತ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ನೋನ್ ಆಸ್ ಅನ್ಸೂಪರ್ವೈಸ್ಡ್ ಲರ್ನಿಂಗ್. Again my screen is disconnected, I think.
Yes sir.
Okay. Network issue. Sorry for the inconvenience. Okay. Now there exists one more learning method is reinforced learning. Reinforced learning is nothing but the hybrid version of the aforesaid learning, means supervised learning as well as the unsupervised learning. Here teacher is there, but teacher is not going to say what is the output. Teacher will not specify anything, but teacher will indicate whether you have adopted the right path or wrong path. By having that particular information, means the teacher involved here, but teacher will not give you any idea regarding the output, but teacher informs whether that whether you are going in a right path or wrong path. So that indication will be taken from the
ಯಾವಾಗ್ಲೂ ಒಂದೇ ತರ ಇರೋದ್ ಕಲಿ ನೀನು. ಸುಮ್ನೆ
that kind of what do you call information will be received from the teacher in a reinforced learning. So reinforced learning is a hybrid version of supervised learning as well as the unsupervised learning. In supervised learning, we have the teacher. Unsupervised learning, no teacher. Network is going to learn by itself. And reinforced learning, teacher involved, but no information regarding the output. But it says whether you have taken the right path or wrong path. By that, you need to learn. So these are the three types of learning we have in a artificial neural networks. So this is the structure of a multi-layer neural network. As you can see here, in this particular diagram, we have the three layers: input layer, output layer. In between the input layer as well as the output layer, you are going to have the hidden layer. So this is the simple structure. You can have multiple hidden layer also. Based on our requirement, you can also have okay. Based on our application, these number of neurons in the input layer, number of neurons in the hidden layer, number of neurons in the output layer, they varies based on our application. Okay, so these multi-layered neural networks, they normally used for these kind of applications: prediction, classification, as well as the function of approximation. I will just take a case study later, in which I discuss pattern recognition system using the multi-layer neural network. So again, these multi-layer neural networks are normally termed as feed-forward neural network. Means here you are going to receive the inputs. Based on the inputs, the input neurons in the input layers can be fired. Some of the neurons can be fired. Some of the neurons may not be fired. They may be in excitation state or maybe in the inhibition state based on the inputs. In turn, all the input neurons in turn connected to all the neurons of the hidden layers. So excited neurons will produce the output and they in turn connected to all other neurons of the hidden layer. Again, what are all the neurons that are present in the hidden layer? All the neurons may get fired or may not get fired based on the inputs they receive. Again, the generated output from the hidden layer in turn connected to all the neurons of the output layer, through which some of the output layer neurons can be get fired or may not get fired. So this is the scenario. As the signal passes from input neuron to the hidden layer neurons, again from the my screen is disconnected. Please bear with me. Network problem. So again, in order to train Normally, these multi-layer neural networks are uses the supervised learning method. Supervised learning method means the teacher involved. So in that, the very popular algorithm which we are using for training the multi-layer neural network is back propagation algorithm. Many of the slides which I am having later, they are having the same information in these slides which I have already explained to you. And one more information, all these links means all these links are going to have the arbitrary weights. Every these links are going to have arbitrary weights. During training, these weights are going to get altered, for which we are using the algorithm. The most widely used algorithm is back propagation algorithm, which I am going to discuss. So, about the weights, means every link is going to have arbitrary values. They are termed as weights. So, as I told, learning is the process of modifying the weights in order to produce the network that performs some function. So, weights are going to alter in the learning phase in order to get the required output. Feed forward network. For which we need some preparation, means for the back propagation algorithm, we need to have data sets. Data sets are nothing but the input patterns or images, whatever it may be. It depends on our problem domain. So those data sets should be categorized into two sets. One is called as training set as well as the another one is called as testing set. Training set normally contains more number of samples, whereas the testing set contains very few, few samples. So like this, our input data set should be categorized into two categories. One is known as training set and another one is the testing set. So these training sets are used to train the multi-layer neural network. So this is the algorithm. Normally what happens in back propagation algorithm means, normally it is known as error back propagation algorithm. So for which I need that particular diagram. See here. We are going to present the data as an inputs here. So the data samples are taken from the training set, not from the testing set. Data samples from the training set will be taken. They are going to present as the inputs for this particular multi-layer neural network. So on receiving those data, the input layer in turn produces the what we call signal. That signal in turn propagates through these links. These links in turn contains the arbitrary values of weights. Based on that, the hidden layer will generate the output. The generated output in turn passes through these links to the output layer. Again, these links contains the weights, arbitrary values. Based on that, the output layer produces the output. When you get the output, on presenting the input, these inputs are selected from the training set. On presenting these inputs, obviously you will be getting the output. When you don't get the expected output, means you already know that is what the supervised learning is. So in the supervised learning, you should know what should be the output. When you get the output, you have to compare that particular output with the required output. If it is the required output, then obviously error is 0. When you are not getting the required output, obviously you will be having the error. So you may have minimum error, or you may have some a large amount of error. So based on the network performance. So if you get the 0 error, means what are all the arbitrary values of the weights which you have already initialized in your multi-layer neural networks are not going to alter. Why? Because you are already getting the expected output. If you are failed to get the expected output, then it will leads to what you call the error. Error magnitude varies from minimum to maximum. So if your error is maximum, means that error magnitude will be taken in a backward direction. That is from output layer to the hidden layer, from the hidden layer to the input layer. By taking that particular error magnitude, the weight, the arbitrary weight values which are present in these links are going to get altered. The what you call intensity of variation in the weights of these arbitrary values depends on the error magnitude. If the error magnitude is more, means more number of alteration to the weights. If the error magnitude is less, means there exists a less alteration to the weights. So in that way, error magnitude will be calculated, and that error magnitude will be taken back from output layer to the hidden layer, from the hidden layer to the input layer. So therefore, normally this back propagation algorithm is also known by one more name called error back propagation algorithm. In error back propagation algorithm, what happens? The error will be calculated based on the output, and that error magnitude is propagated in a reverse direction. That is from output layer to the hidden layer to the input layer. So not only that, based on the error magnitude, in that by using that particular algorithm, the weights are going to adjusted. Weights are normally perturbed intensively when error magnitude is more. That intensity is very less when error magnitude is less. So this particular process is having some technical what you call terms called epochs. Epochs means when you present the input, and that input leads to an output. If you based on the output, error magnitude will be calculated, and that error magnitude will be back propagated from the output layer to the hidden layer, and hidden layer to the input layer, and the weights of these links are going to get altered. This process is
Hello, sir.
so this process continues. So these are known as epochs. Many number of epochs are required to train a given neural networks. You are fortunate if you have less number of epochs when you train a neural network, but normally you will be having several number of epochs. After having several number of epochs, your network will converge. Convergence means your error the output, the error magnitude will get reduced, but there exists a chance that even after training, the error magnitude may also increase. So in that case, we say that our neural network is not going to converge. During that period, we are going to adjust some neural network parameters like what you call learning coefficient. So there exist so many such neural network parameters are there. So we are going to adjust them. Anyhow, with those circuits, we will make our neural network to converge. Convergence means when we call our neural network is converged means our error should falls below the what you call our requirement. Means normally in ideal case error should be 0. Normally we will not get 0 error in our neural network. It should be within the tolerable range. When our error magnitude reaches to our tolerable range, then we can say our neural network have been converged. So this is how what you call back propagation algorithm works, for which in one of my slide I have put the pseudocode, but the diagram is necessary to explain it. So this is the pseudocode for the back propagation. And previous one means multi-layer neural network, which we discussed till now, is come under supervised learning method. There exists one more topology called Cohen neural network, which falls under unsupervised neural network. The structure of a this particular structure is also known as SOP, self-organizing feature map anta kariತೀವಿ. So we call it as SOP, self-organizing feature map, which normally contains output vector like this, and there exist input nodes. For the bin, all the input nodes are going to have the connection to these output nodes. This is all these lattice varies based the number of nodes in this particular lattice, output lattice it is called as. The number of nodes in this output lattice varies based on our application. Whatever the application we have in our hand, based on that the output lattice varies. 100 cross 100, 1000 cross 1000, 50 cross 50. If you consider 50 cross 50 lattice means it contains around 2500 nodes, something like that. Based on the what you call problem in our hand, this particularly the size of this output lattice varies. This structure is known as Cohen neural network. Cohen is a mathematician who proposed this particular structure, and this is a very popular network. Falls under what we call unsupervised learning category. So without a teacher, this particular neural network will learn by itself. the algorithm goes like this. So what do we do here? Also, we will be having two sets of data. One is training set as well as the testing set, very similar to that of the multi-layer neural network which we have discussed previously. For here, we are going to present the data to these input layer by selecting the samples from the training set. They are present, they pass through these links to the output nodes. So these are all neurons. On receiving the signals from the input neurons, some of these, one or more number of neurons may get fired or not fired. Normally, one or two neurons going to get fired. Assume that this particular neuron is going to get fired means we are going to have a radius, means we are going to consider the neighboring nodes of this particular neuron. Means if this particular neuron gets fired on presenting the inputs, means we are going to consider the neighboring nodes. Normally, what do we do is we are going to consider entire size of the lattice, and then we started altering the weights so that only the neighboring nodes of this particular node is going to fire next time. So that can be done. There exist some mathematical equations how it can be done. So we normally start with the size of the lattice, and that size is, gradually reduces, and it will what you call, it will come to neighboring node of what you call the fired node initially. So many epochs will take so that the grouping will happen. ಅದಕ್ಕೆ ಕನ್ನಡದಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಡೋದಾದ್ರೆ, ಈಗ ಇನ್ ಅವರ್ ಆರ್ಗನೈಸೇಷನ್ಸ್ ಏನ್ ಮಾಡ್ಕೋತೀವಿ ಅಂದ್ರೆ, ನಾವು ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ಸೋ ಮೆನಿ ಗ್ರೂಪ್ಸ್. ಅಂದ್ರೆ ನಮ್ಮದೇ ಕಾಲೇಜ್ಗಳಲ್ಲಿ ನಾವು ಒಂದಷ್ಟು ಜನ ಫ್ರೆಂಡ್ಗಳು ಗ್ರೂಪ್ ಅಲ್ಲಿ ಇರ್ತೀವಿ. ಒಂದಷ್ಟು ಅದೇ ತರ ಸುಮಾರು ಗ್ರೂಪ್ಗಳು ಆಗಿರುತ್ತೆ. ಅದಕ್ಕೆಲ್ಲ ಇವ್ರ ಜೊತೆ ನಮ್ದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಮ್ಯಾಚ್ ಆಗಿರುತ್ತೆ, ಆ ತರ ಹೇಳ್ತಿರ್ತೀವಿ. ದ ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಈಸ್ ಇನ್ಕಾರ್ಪೊರೇಟೆಡ್ ಹಿಯರ್. ಸೊ ಫಾರ್ ವಿಚ್ ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ಅನ್ ಅಲ್ಗಾರಿದಮ್. ಆ ತರ ಒಂದು ಗ್ರೂಪ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಗ್ರೂಪ್ ಈಸ್ ನೋನ್ ಆಸ್ ಬೆಸ್ಟ್ ಮ್ಯಾಚಿಂಗ್ ಯೂನಿಟ್, BMU ಅಂತ ಕರಿತೀವಿ. So we will call it as a best matching unit. That will happen. That will happen through an algorithm. That algorithm is normally known as Cohen algorithm, unsupervised algorithm, and the pseudocode of this algorithm given here step by step manner, which I have already discussed by taking this particular structure. This is the pseudocode. Winning node means whenever you will give an input, one of the neuron will be get fired in the output lattice. That is what we know as winning neuron. So competitive learning anta kariತೀವಿ ಇದನ್ನ. That neuron will be considered, and we'll take the radius. Radius is obviously the whole size of the lattice, and then it will reduces and it will converge, means it will get saturated at some point. And in that minimum radius, what are all the neurons which are within that particular radius, they are all come under what you
Hello, sir.
ಹಾಕ್ಯಾರ ಅಂಕಲ್.
Dear participants, sorry for the technical glitches. Sir will resume soon.
Now is it visible, sir? Hello.
Yes, sir, it's visible.
Okay. So grouping will takes place. So, say for example, assume that we are presented the input in such a way that they're supposed to make grouping of different colors. In that we have you can see the grouping here: red color, blue color, green color, yellow color, as well as the pink color. So these kind of grouping will automatically happen on learning uh, whenever you show a different color. Whenever you show a different color by selecting the sample from the testing set. Say for example, if I take the sample from the testing set, it is of red color, means when I uh, present it before the coherent neural network, then it is required that the neurons, number of neurons, there exist so many number of neurons. You can see the assume the I think ನನ್ನ ಮೌಸ್ ಪಾಯಿಂಟರ್ ನಿಮಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. That my mouse pointer is visible now. Hello, please respond. Sir? Yes? Hello, sir.
Tell me, sir. Tell me, sir.
Sir, mouse pointer ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ?
Yes, sir. ಕಾಣ್ತಿದೆ.
Okay. So when I take the sample from the what you call testing set, and if it is of red color, then the neurons in this particular group should get fired if your Cohen neural network is properly trained. If it is fired in any other group, means that is what we known as error. When your Cohen neural network is properly trained, means when you present a new data which is of red color, then the neurons which are belongs to this particular group, one of the neuron belongs to this particular group, get fired. When the that particular neuron get fired, means obviously what is the output, means whatever the data which you have given, then we consider that particular Cohen neural network is properly trained. If some other neuron get fired, means other than blue color, means it is an error. So this is what the process involved in unsupervised learning. So you can see this particular grouping. So this kind of grouping groups, the pink groups are visible only in this particular part. So like that, by varying the network parameters, we can have the grouping like this. So this is a typical example for unsupervised learning. That is Cohen neural network, normally called as self-organizing feature. Next comes the convolutional neural network. We have extensive deliberations yesterday. Even I was also present in the yesterday's presentation. Chetan from JNCE, very good friend of mine, presented very well deliberation on the convolutional neural network. These are the neural networks. What are all the networks I discussed, means multi-layer neural network, Cohen neural network, they are the conventional neural network. Nowadays, all these neural networks are replaced with these new variety, that is convolutional neural networks. These convolutional neural networks are having more advantages compared to the conventional structures, which I have discussed. Two topologies. One is a multi-layer neural network, and one is Cohen neural network. These convolutional neural networks are having more advantages over the conventional structures. So therefore, these CNNs are replacing the conventional structures. Let me again brief out the working of convolutional neural network. The structure like this. Simple structure I am speaking here. It is having the input layer, normally an image. If it is the image processing problem, which is in turn fed to a convolutional layer, where which convolution operation happens. What is the convolution? All of you know. This comes under DSP, digital signal processing, as well as the signals and system convolutional operation. It is in signals, which is a single one-dimensional entity, whereas we are speaking of image. Image is a two-dimensional entity. Here, convolution is slightly different. For the convolutional operation, we have the kernels of smaller sizes. Images are normally large in size, so we are going to select kernels. These kernels normally are of odd in size, means 3 cross 3, 5 cross 5, 7 cross 7, as well as the 9 cross 9 kernels. Kernels also matrix, they are nothing but the small matrix of size 3 cross 3. So these matrices are going to traverse around the image. Stride 1, stride 2, all these discussions we had in the yesterday's presentation. Convolution operation happens with the original image as well as the kernel. Kernel values as well as the image values are going to convolve, resulting in a new values. And there comes the what we call padding regarding padding, zero padding. So that also we need to do. Why? Because when you take the kernels, in order to cover whole image, it is very essential to what we call join zeros or concatenate zeros row wise as well as the column wise at the edges of your image. That is what is known as padding, zero padding. So that, we need to do in order to cover whole image. So convolution operation happens in this convolutional layer, output of which is in turn given to the max pooling layer. Max pooling layer, what is going to happen? That also been discussed extensively in the yesterday's afternoon presentation. There exist two types of pooling. It is max pooling as well as the average pooling. This in this layer, in turn, the values are going to reduce in a greater extent. When you have minimum number of values, so further processing is easy. Why? Because when we talk about image itself produces a very huge amount of data. The processing of those huge amount of data is not a simple job. So therefore, normally what do we do is we normally going to reduce the normally we are going to reduce number of what we call data. So that will happen in a max pooling. There exist two type of pooling, max pooling as well as the average pooling. Here, the data to be processed in the next stage is reduced to the greater extent. We will be having fully connected layer here. That is normally known as dense layer. This is very much similar to that of the multi-layer feed-forward network which we discussed earlier. The same kind of training weight adjustment happens in this, and that leads to a required output. This is what the overall working of a convolutional neural network. They are playing a very important role nowadays. They are replacing the conventional structures nowadays. So all the things I just discussed, mentioned in these slides. So this is the process of pooling. Max pooling have been indicated So with numerical example, if you take the 2x2 kernel, when it traverses with this image, when you put the kernel in this 2x2 size, in a max pooling, what it will do means it will select the maximum value. In these 4 values, 6 is the maximum that comes under here. And the same kernel moves to this position. And again, in this maximum value is 8, that comes under here. And the same comment holds good for this portion as well as this portion, 3 and 4. So you can see here the number of values that can be processed further is used in a greater extent. See here, 4x4 means 16 values are there. It is greatly reduced to only 4 values. So that is what the job of a max pooling layer, and that in turn given to the dense layer. It is a fully connected layer that will be working very much similar to that of multi-layer neural network, which I have already discussed earlier. This is just an example. Here our intention is to recognize an object of this particular input image. In this particular input image, there exist so many objects. Road is there, car is there, trees are there, hill is there, sky is there. So our intention is to recognize this particular object, that is car, and that is in turn given as an input to this convolutional neural network. This automatically takes that data and based on the ethical algorithm, it will learn by itself. I mean, convolution happens. There is just one more layer, rectified linear unit. This is known as Dept. So all these layers are going to have the weights, and they are then pooling layer is also there. So multiple stages of CNN are adopted here. And finally, outputs are coming like this. The more probable values we are going to consider as the correct value. So there exist so many classes here: car, truck, airplane, ship, horse, like this. But car is having the maximum probability, so that is the correct category. Example ಕೊಡೋದಾದ್ರೆ ಕೋಟ್ಯಾಧಿಪತಿನಲ್ಲಿ ಪಬ್ಲಿಕ್ ಒಪಿನಿಯನ್ ಅಂತ ತಗೋತೀವಿ. ಅಲ್ಲಿ ಪಬ್ಲಿಕ್ಸ್ ಫಾರ್ ದ ಗಿವನ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅದು ಪ್ರಾಬಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಇನ್ ದ ಸಿಮಿಲರ್ ವೇ, so here maximum probability is available for car, and this is the correct classification. This is how we are going to recognize this particular object in this. This is a simple example, and then comes the case study, pattern recognition. But I am running out of time. I think if you want, I will just continue, and I will just go through one case study which is selected from my research area. Is it okay, sir? Shall I proceed or shall I wind up? Yes, sir. I wanted to produce I want to discuss one case study. Is it okay or not? Why? Because I am running out of time. Am I audible?
Yes, sir, you are audible. Yes, sir, you are audible.
Shall I proceed or shall I wind up?
Yes, take 5 more minutes.
I want to discuss this one case study. That's it.
Okay, sir.
No response.
Okay, sir.
So here I took handwritten character recognition as a case study that comes under pattern recognition system. In pattern recognition system, normally there exist two type. One is offline recognition as well as another one is online recognition. In offline recognition, what do? Is we are going to capture the image using the camera, and that will be presented to the pattern recognition system. And that pattern recognition system will recognize the object. In online, what do? Is in a real time. In a real time, we are going to write some patterns on some board-like structure, and your pattern recognition system will recognize that particular pattern. What are all the patterns you are going to write in real time? That is what we know as online pattern recognition. Offline pattern recognition means you are going to capture the image first, and you do some pre-processing, and you are going to present it to the pattern recognition system, and it will recognize it. And we have the handwritten character recognition, which is a very tough job for any pattern recognition system. Why? Because all as a human being, we are going to write the patterns in different styles. It's very challenging job for the computer to recognize what are all the patterns we are going to write with our hands, means handwritten. So one example is handwritten numeral recognition system. These are the sample data set. You can see here various patterns are visible here, starting from 0 to 9. Various styles of patterns are visible here. So now it is the problem of handwritten pattern recognition. The typical block diagram goes like this. We are going to give a raw data for the pre-processing stage. In a pre-processing, we do some pre-processing in order to remove some noise and all. So after fine-tuning my raw data, I will give it to the next stage. That is nothing but the feature extraction stage. In the feature extraction, what do? Is raw data normally contains very large values. Those large values are going to reduce to the small amount in feature extraction. Those small amount of data in turn given to the classification stage. Here we are going to have some classifiers, neural networks, like that. There exist so many hidden Markov model, like that, k nearest neighbor classifier, like that. So you can also use the neural network for the classification purpose. So in we are going to present the output of the feature extraction to the neural network classifier. Neural network will be trained, and it will after that it will start recognizing the input data. So this is what the typical block diagram of the any pattern recognition system. As I told, in pre-processing, we come across these many number of stages: image rotation, image thinning, image normalization. Why? Because in image rotation, what do? Is we are going to correct the position of the patterns. Some of the human, there exists some slant rating, like, so those slants can be corrected. So by having the rotation technique, we are going to make it straight. Image thinning. So many types of styles of handwriting you can have. So there, thick type of patterns can be thinned. That can be done in image thinning process. And normalization means we need to give uniform size of images to the pattern recognition system. These images of different sizes, those different size of images can be normalized to the uniform size. That is done in image normalization technique. that in turn given to the feature extraction. One feature extraction I would like to discuss here is barcode based feature extraction. I would like to take the numerals. Numerals are the binary images which contains zeros and ones. Those zeros and ones are going to present like this. Here you can see the matrix. Matrix, for example, it is having 7 cross 7 matrix, which leads to 49 values. Those 49 values are in turn reduced to the to a greater extent. You can see here black shades are nothing but the feature values. Around 17 features you are going to get out of this particular structure. I will tell you how to extract the features with this particular pattern. This is the proposed work of my research. A novel approach it is. So you can see here. So you can see the numeral 1 here. So numeral 1, I think it is visible to all of you. Numeral 1. Wherever you have the dark shade, there you are getting ones, and wherever you have the white shades, you are going to have the zeros here. So this particular pattern is to this, and we are going to choose what you call the kernel. Kernel here it is a 3 cross 3 kernel. When you move these kernel all over the pattern means, so I have taken one kernel of size 3 cross 3. You can see here only one cell is having the value 1 and remaining all are zeros. You can see here. So if I put my kernel here, see here. If I put the kernel here in this 3 cross 3 size, you are having all the zeros apart from this value 1. So with this, I am going to calculate one feature value, that is F1. What is that feature? Feature is sum of the values of on cells divided by sum of the total value. On cell here in this particular kernel is only 1. 1 divided by 9, which leads to the feature value 0.1. 0.11 is my first feature. Like that, I am going to calculate the 17 features like this using this particular pattern. These 17 features will be given to the classification stage, wherein which I am making use of the multi-layered feed forward network, and have made use of back propagation algorithm. I will just made use of training set as well as the testing set. I have discussed already how back propagation algorithm works. Training process I undergone. After the training process, in a recognition phase, I am going to present the test sample for my neural network. If my neural network is properly trained, then it will recognize that particular presented new pattern is 1. Otherwise, it will recognize it as a 2 or 3 or something like that. So when I present the pattern as 1, and if it is recognized it as a 1 means it's a correct classification. If that pattern is recognized as 2 means it's a misclassification. So like that, the numerals can be recognized. So that is what my case study presentation. Now I come to an conclusion part. So the conclusion here is I have discussed in my presentation various digital image processing phases. In these phases, how we can involve the artificial intelligence. One way of involving the artificial intelligence is making use of an artificial neural network. Artificial neural networks are mimicry of mimicking the artificial, human brain into a computer system. That's it. This is how we can incorporate artificial intelligence in digital image processing. And there exist a major, there exist various types of artificial neural network based learning method. Those major types we have discussed, and I just discussed one case study, that is handwritten numeral recognition system. With this, I would like to conclude my presentation. Thank you all the participants for your patient hearing. I'm open for the any queries.
Dear participants, any queries? If no queries, sir, thank you for your insightful and enriching session. Thank you, sir. Thank you, Shridar Murthy, sir. Our department HOD, Dr. KV Siddesh, sir, will speak now. Hello, Shridar Murthy, sir.
Yes, yes.
Yes, sir. You have given us a wonderful session and a lot of information about the image processing using ANN. And our participant participant will get a lot of benefit from that. So please keep the support in the next future FDP, sir. Please, thank you.
Thank you,
Thank you.
sir. Thank you.
Thank you. Thank you. Participants, the feedback link will be it's been shared in the chat box. Kindly fill the feedback. Another 5 minutes will be there. We will close the session.